Hi students, this is another question for helical gear. I can read the question. Design a pair of equal diameter 20 degree stub teeth helical gears to 7.5 kilowatt with moderate shocks at 1200 rpm. The two shafts are parallel and 0.45 meter apart. Each gear is made of steel with beta, that is equal to 30 degree. Alpha is given, that is equal to 20 degree stub teeth. Then power is given, that is equal to 37.5 kilowatt, and the speed of the pinion, that is N1, is equal to 1200 rpm. Then the service is a moderate shock, that is also directly given in the question. Then the center distance they are given, that is equal to 0.45 meter, or we can take it as 450 mm. Then diameters are equal diameter. Then helix angle they are given, that is 30 degree, and we have to design a helical gear. Here the speed ratio I is equal to N1 divided by N2. Here the D1 and D2 are same. So from this equation we can directly set it as Z1 is equal to Z2 or I is equal to 1. Sorry. Then the center distance is given. So using this equation, that is D1 plus D2 divided by 2 is equal to 450 mm. So from this equation we can take the value D1 and D2 are is equal to 450 mm. Then next, material property. Since the both material and gear are made of same material, that we can take it as a steel and assume it as a carbon 45 untreated steel. So from data book table 12.1 we can take the value of sigma D1 and sigma D2, that is equal to 233.4 megapascal, and BHN1 and BHN2, that is equal to 200. Then we can find the weaker part, that is the main step included in the design of gear. Here we know that the strength factor is equal to sigma D into Y, but in this case also the pinion and gear are made of same material. So for a same material we have to design the pinion, not go for any gear or other. So assume Z1. Here the number of teeth is not given, so assume the value of Z1 is equal to 20. Then using that equation we already calculated it as 1. So from that equation we can calculate the value of Z2, that is equal to 20 teeth. After getting the number of teeth, we have to find the Versuel number because it is a helical gear problem. So using this equation, that is 12.52a, using this equation we can find the value of Versuel number of teeth. Using this equation we will get it as 31. Then next we can calculate the value of module. M, we can find this equation from the equation 12.60. Mn is equal to sigma square root of Ft into Cw divided by sigma d into Cv into k into y. Then we know V is equal to pi dn by 60, and here the value of V is equal to 28.27. So it is greater than 20 meter per second. So using this equation 12.61 d, we can use this value for the Cv. Thus we can calculate Cv. After that we can calculate Ft. Ft is equal to 1000 PCS divided by V. The question already given that it is the system is under moderate shock, and assume it is 8 to 10 hours service. So we can take the value of CS is equal to 1.5 from table 12.8. So this take this table and identify from where we got that value. Then next we can find the value of Ft. We can find the value of Ft. Using that equation we will get it as 1989.74 Newton. After that we can find form factor, that is equal to Y is equal to pi into Y1. Here the 20 degree stub tooth system. So the value taken from the equation number 12.17c, that is equal to pi into 0.175 minus 0.95 divided by Z1. Then using this equation we can find is Y. Then assume the value of k is equal to 15 because it is a helical gear. Then next assume Cw is also assumed as a 1.15. We can directly take that value from table 12.21. You can write that in the right side of your assumed assumption. Then using these values we can find the value of Mn, that is equal to 2. Then we can go for number of teeth on pinion, that is Z1, that is equal to 195 teeth. Then number of teeth on gear, because Z1 and Z2 are same, so number of teeth on gear also 195. Then we can find the virtual number of teeth. The value of beta is given, that is the helix angle. So using this equation we can find the value of ZE1 and ZE2. Both are same, that is the formative number of virtual number of teeth. And next we can find the value of B, that is face width, that is equal to 15. We assumed K is equal to 15. So from that equation we can take the value B is equal to 15 mn. Then that is equal to 30. B value of B is equal to 30. After that we can check for B, that is equal to B minimum. That is equal to 1.15 pi into mn divided by sin theta from equation number 12.54. Then using this equation we can find B minimum. So our value B minimum, since the B value of B from the assumed section, it is greater than B minimum, that is a calculated value. So our design is safe. Then next sigma D1. Using this equation, that is 12.59, we will get the value of Ft is equal to sigma dCv by mn divided by Zw. And using the values that we already calculated and we our known data, we can find the value of sigma D, that is equal to 138.34 megapascal, which is lesser than 100 megapascal, which is greater than 100 megapascal. Since the calculated values are lesser than the permissible value, assumed values are satisfactory. Then next we can go for the face width. B is equal to 30 mm. Sorry, please wait. Sigma D is equal to 233.4 megapascal. So here we have one problem, that is they are right, this value is 100. It is not 100. Sigma D, value of sigma D is equal to value of sigma D, where it is, value of sigma D is equal to 233. So which is less than, so this value is wrong, not 100, that is 233 point that we assumed from the data book. So from that value the design is safe. This value is wrong. Please listen, this value of 100 megapascal is a 100 is not right, here it will come, that is 233 megapascal. Then next we can go for the FD, that is dynamic tooth load. Dynamic tooth load FD is equal to FT plus K3V. This equation we can take from data book, and just below that data book all the values are given. Using these values we can find the value of FD. Okay, FD is equal to 6130.51 Newton. Then next we can calculate FS. FS we can calculate this equation, that is 12.63. That is the endurance strength, that is equal to sigma En B into Y into Mn. Here the BHN1 is equal to 200. Then sigma En is equal to 345 megapascal. That we can take from the table 12.15. You can take the data book and take that value from the data book itself and use that values. Thus we will get Fs is equal to 11.17 kilonewton. Here the Fs is greater than Fd, kilonewton. The material is safe against static tooth load. Then next we can find for the dynamic wear load. Oh, some errors are here. So this one is wear load Fw. So from table 12.64 we can take the value of Fw is equal to d1 bq divided by cos square beta, and using this equation we can find the value of Fw. The values for q and k we can calculate. Q can calculate using that equation, and the value of k is directly taken from table 12.16. Then Fw is equal to 450 into 30 into 1. Using this equation we will get Fw is equal to 9702 Newton, which is greater than Fd. So again the material is safer. Thank you for watching.